Here we are in our last video in section 9.1. Again, just getting all the conceptual things down before we get into the mechanics of actually doing the test of significance. Today we're talking about type 1 and type 2 errors. Now, this is one of the areas where you're really going to want to try to keep track of and come up with something to help you remember the difference between a type 1 and type 2 error. So if we reject the null when the null is actually true, so rejecting the null when the null is actually true, notice we have made an error. We have done something wrong. This is your type 1 error. Now in the next case, we fail to reject the null when the null is true. If we fail to reject the null and the null is true, then we haven't done anything wrong and we have made a correct conclusion. Or if we reject the null when the null is false, then again we've done nothing wrong and we've made a correct conclusion. And the last situation we can come to is if we fail to reject the null when the null is actually false. That is called making a type 2 error. Now when we're doing a test of significance, we're always making these decisions, we're making these conclusions based on our p-value and judging it against an alpha level, just like we went over in the last video. So if our p-value is low, then that means that it's very rare, it's very unlikely that it happened by chance alone. But we all know if there's still a probability there, then that means it is possible for it to happen alone, on chance alone. So that means it's maybe not very probable, but it doesn't mean it's impossible. Remember, after all, somebody wins the lottery. So you can make an error because we're making these decisions purely based on mathematics. We're making it based on numbers. So if you make an error, then it's whether is it a type 1 error or is it a type 2 error. And both errors come with their own sets of consequences. So a type 2 error occurs when you fail to reject the null when you really should have. Notice type 2, you fail to reject. Just one way to maybe try to help you remember it. Or when the p-value is low, it is possible that we make a type 1 error. 1 is lower than 2. So again, maybe a way that might help you remember this. When the p-value is high, it is possible that we make a type 2 error. 2 is higher than 1. So come up with your way of trying to help you remember it. These are different possibilities. And then the probability of a type 1 error is alpha. The probability of a type 2 error is power. Now remember that alpha is that alpha level that you're setting. That's the same alpha that we're referring to. And as far as power goes, you don't really have to worry about having to calculate power, but you do need to understand the concept of what power is. So remember, the probability of a type 2 error is your power. Now the other thing I wanted to go over with you is bringing this back to the court case example I talked about before. If we're dealing with a court case, then a type 1 error would be to find somebody guilty when they're actually innocent. Think about the people who have sat in jail for 30 years for murder, and then some evidence comes up, or they finally run the DNA and they're able to figure out that this person was not actually the killer. How bad would that be? What kind of consequence is that? Now the probability of a type 2 error is to find not guilty when they actually are guilty. So someone, a murderer perhaps, gets released out on the streets because we didn't have enough evidence to be able to put him away. So if you kind of relate it back to that, that might be one way of helping you remember. A type 1 error is the guilty person, the innocent person who goes to jail. And a type 2 error is the guilty person who's allowed to walk free. So to bring this through an example, maybe help you connect to it. We're going to state the hypotheses for a significance test to determine whether first responders are arriving within 8 minutes of the call more often. Be sure to define the parameter of interest. So again, we're checking to see our first responders arriving within 8 minutes. So our null hypothesis is always a statement of equality. So we have to say that our null is that the mean is equal to 8. That means we're testing it against our alternative of that it's greater than 8. Because we want to see, are they making it within 8 minutes? So we're saying, is it equal to 8 or is it actually longer than 8? And to define that parameter of interest, we have that mu is a true mean response time of the first responders to an accident. Now the next stage of this is we're going to describe a type 1 error and a type 2 error and the setting and explain the consequences of each. So let's go back to it. A type 1 error is when we reject the null when the null is actually true. So remember, that was the equivalent of finding somebody guilty when they were actually innocent. A type 2 error was to fail to reject the null when the null is actually false. And that was when we had the guilty person walking free. So in this case, mu is equal to 8. We would we would reject the null when the null is actually true. So we would reject that this is happening when it actually is true. So they actually are arriving within the 8 minutes, but we say that they aren't. And the type 2 error would be that we failed to reject the null when the null is false. So we're saying they are actually arriving, but they aren't. So to put that into context, a type 1 error, finding convincing evidence that the first responders had a mean response time greater than 8 minutes when it really wasn't. A consequence is that the city spends time and money investigating other methods to reduce the response time when they aren't necessary. A type 2 error is not finding convincing evidence that the first responders had a mean response time greater than 8 when it really was. A consequence is that the city may not investigate other ways to reduce the response time and more people could die.